Guten Tag, meine Damen und Herren. Ich begrüße Sie zur WK-VIP-Bühne auf der Embedded World 2025. I will switch to English now. My name is Andreas Knoll. I'm editor for Embedded Systems and Industry 4.0 and Industrial Internet of Things. And welcome to Avijit Sinha, Head of Strategy and Business Development at Wind River.
Well, thank you, Andreas. It's great to be here.
Okay, thank you. Avijit, why is AI at the edge a better fit for mission critical systems versus AI in the cloud?
Yeah, look, that's a great question. And look, for mission critical systems, what's really important is safety, security, reliability, and performance that's consistent over the life cycle of a particular asset. Because in mission critical systems, a particular device or an asset is operating in a dirty, difficult, and a dangerous environment. Whether that's a aircraft or it's a mining equipment or something in a health scenario or an autonomous driving vehicle. These are scenarios where human beings are operating with machines in an environment where if something goes wrong, lives can be at stake and human beings can be harmed. And therefore, software there has to be very reliable. So when you look at AI, if AI is just in the cloud, just the sheer latency and the throughput and the bandwidth at the edge will cause a lot of latency in commands being executed. So it's very important that AI that's trained in the cloud is deployed at the edge and is able to work without needing connectivity to the cloud. Because if you're dependent on the cloud, you might not be able to react in milliseconds or microseconds in real time to the scenario. So AI at the edge is very different than AI in the cloud, and it's really important that AI at the edge is safe, reliable, secure, and performant in a disconnected scenario. That's why AI at the edge is very different than AI in the cloud.
Okay, but it's mostly a latency problem more than a safety and security problem. Is that right?
You're absolutely right. There are a couple of other aspects too. So if you think about AI today requires large data centers for training, where there is elasticity of compute, storage, networking, and memory. But when deployed at the edge is very constrained in terms of all of those requirements. There is limited storage, there is limited compute, networking, and the latency points that we talked about, and then even memory. So you really need to make AI fairly compressed to be able to run in that resource-constrained environment. So in addition to safety, security, reliability, and performance, it's the resource constraints at the edge that make it very critical for AI to be run in a performant manner.
Okay. And how do you see the intelligent edge reaching its full potential?
Look, I think the intelligent edge will reach its full potential when we have a horizontal platform that goes all the way from the sensor to the cloud and everything else in between. And by that, what I mean is from the sensor to the device, to the gateway, to the far edge, the near edge, the telco, mobile edge compute environment, and the public cloud or the private cloud environment, right? If you have a horizontal platform that scales across that spectrum from east to west, then when you have from south to north, meaning all the way from silicon and sensors and hardware to every other layer that goes up to the cloud and AI runtimes, that's when you'll be able to realize the intelligent edge, because you can develop AI in the cloud, given all the benefits of the cloud, but then be able to package and deploy it at the far edge so that it can run in a disconnected manner. That is truly when the intelligent edge will come about, where training can happen in the cloud, but inference can happen at the edge, and then all the AI capabilities that are being built in by the semiconductor providers in the silicon can be exposed through an operating system and an organizing layer such that applications can be AI enabled. That's really when the intelligent edge will come to life.
Okay. And what value will the intelligent edge deliver to organizations?
Yeah, look, there's going to be a tremendous amount of value. The reason for that is this. Up until now, embedded systems have had essentially statically developed code or dynamically executed logic disconnected from the cloud for, once it's developed and deployed, it's left like that forever. So it's a very confined environment. It is a deterministic framework within which it works, and it does a few things consistently over years and years. But now with a lot of sensors like cameras and even simple things like gyroscopes and vibration sensors or even microphones being there, the asset is operating in an environment where it can sense the environment. Now, when you get very different signals, wind patterns may be different, noise patterns may be different, visual input might be different. And the application, if it's statically compiled, it can only do a few kinds of things. But when it's AI enabled and it has all of the AI models which are multimodal and are able to react to sensory inputs like voice and sound and visual input, then the application can be very intelligent. That opens up a host of scenarios where an asset that's deployed in an oil refinery or even an autonomous vehicle is now very smart about operating in that environment because it is not just operating on a fixed logic, it's able to sense the environment, perceive it, and react to it. And so that AI embedded in it gives it that intelligence. And that is really what is going to be having impact across industries. So all of these assets are going to become smarter and more intelligent and be able to react to the context in which they are operating.
Okay. And why is the edge infrastructure currently development into alternative to the cloud for the use of AI?
Yeah, look, the reason for that is many of the things that we just talked about, which is AI is birthed in the cloud because of all the benefits that the cloud provides in terms of elasticity and storage, compute, and networking, right? And these large models that have trillions of parameters and such. That infrastructure is needed for AI that needs to be run in the cloud to service that. But when it comes to the edge, we talked about resource constraints, right? And therefore, it's important that AI operate in that resource-constrained environment in a disconnected fashion. And that essentially means that AI running at the edge is going to be exposed to a whole different set of scenarios where dependency on the cloud is not needed. And in mission-critical industries where if it's a factory floor or a mining equipment or a drone, you can't rely on having connectivity back to the cloud to execute the scenario.
What is an AI runtime and how are AI runtimes embedded in higher level software suites?
Well, look, I mean, AI runtimes are very much like application runtimes, if you will. So they take different forms. Typically, applications used to have SDKs. So AI runtimes also have SDKs. So a semiconductor manufacturer will publish an SDK that allows an operating system or an application to use that SDK to harness the AI capabilities that are there in the silicon, whether it's an NPU working in conjunction with a CPU or a dedicated conclave just for executing, matrix math, if you will. But the runtimes take different forms beyond SDKs. They can be simple frameworks like PyTorch and Teras and MXNet, or they can even be libraries that are used or foundational models. So you can use LLMs that have been built in the cloud, but are then compressed through pruning and knowledge distillation, or even other techniques to make them more compressed and have them execute, for that matter, at the edge. And that's where really the AI runtime is either an SDK or a library or a model that is compressed that allows an application then to use that runtime to execute the AI or to be able to tap into the silicon capabilities or access the sensor. So runtime is multiple things, but that's generally the set of things that constitute an AI runtime.
Okay. A little bit like a runtime in a soft PLC.
Yeah, very much, right? It's a runtime. The word runtime is really to allow an application to, at runtime, be able to execute some logic. Now that logic earlier was static, now it's very dynamic.
Okay. How is an AI at edge infrastructure structured that enables AI at the edge?
Yeah, look, I think, AI at the edge, as we talked about, this notion of intelligent edge, the training in the cloud, inference at the edge. So all of that essentially comes together to make AI at the edge very different than AI in the cloud.
And how is a cloud to edge infrastructure structured that enables AI?
Yeah, so look, in the cloud, you essentially have a large data center with, as I said, elastic compute, networking, and storage. And then on top of that, you have large data platforms, right? Going from simple databases to data lakes that then can be used to cause AI runtimes on top and frameworks to use that to build large language models or even vision models, right? In contrast, at the edge, you essentially have more of a compiled model, right? Which is mostly doing inference. But increasingly, what's happening is now at the AI at the edge, you're also able to do training. So clear examples today that we see in everyday lives. In a mobile phone, you can say, hey Siri or hey Google, or speaker say hey Alexa. That is a wake word, and that's embedded logic that's been trained in the cloud but deployed at the edge. But now training can be done even at the edge because you can tune it to your voice or my voice, and that's training without needing the cloud in the equation. The same thing if you have a Google Pixel phone, you have a lot of images there. Image classification, image recognition is happening based on your data, your pictures on that phone without having to push that data to the cloud or to use anything else from the cloud, right? So that training is happening locally and inference is happening locally. So if you extrapolate that across all of these scenarios across industries, increasingly more AI runtimes will facilitate training at the edge and inference at the edge as well.
How about the hardware? Which hardware is necessary at the edge to run AI models? And do you think there are restrictions about hardware to run large language models and so on at the edge?
Yeah, absolutely. I think, look, the edge, in contrast to the cloud, is very heterogeneous, right? You have everything from microcontrollers to microprocessors to CPUs, GPUs, ASICs, FPGAs, NPUs, and TPUs. So you can see the spectrum of silicon is very different. And so you have to find the right silicon form factor for the right scenario. So that diversity is really good because you could use a microcontroller and a microprocessor with a battery operated environment, and then you need AI now to not just be tiny, but also to be power efficient, right? And so so to speak, diversity of silicon is really what needs to be taken into context when you're building AI for the edge. And so the infrastructure, the key enablement capability is what silicon do you have, what capabilities does it have, and do you have the right operating system and the runtimes that can tap into that capability that the silicon exposes? Because if you don't have that, then applications cannot take advantage of all the innovation that semiconductor companies are bringing into their different silicon that they bring into market.
That means it would be best to know which AI model I have before I consider which kind of silicon I need to run it.
Well, I think it's two ways, right? Either you start with the AI model and use its characteristics and its requirements to define the silicon that you need, or you can go the other way around. You may choose a particular silicon because that silicon might be a function of the environment in which it's being deployed. Is it a microcontroller, microprocessor? Is it connected to a reliable source of power, or is it battery operated? That can then define the power envelope and the compute envelope within which an AI runtime and AI application must perform. So then you go from the silicon up and define what the application and the AI runtime must be. The converse is you could start from the model or the application and the use case and then use that as a way to define what the silicon must be capable of, and then choose whether it's an NPU or a TPU or maybe a GPU that you need in order for that model to really perform on that silicon form factor.
Okay, and that means NPUs are good for that, but not always the best.
Absolutely. Look, it depends on, it's not just the power envelope, it also depends on the cost envelope, right?
Okay.
How much can you, what economic value proposition do you want to bring, and what cost bearing, so to speak, guardrails are in place. And so you'll make your silicon choices based on that. And now what's happening is, CPUs generally have instruction sets that allow you to do basic math. But in NPUs and other silicon types, you can actually do matrix math and vector math, which is really critical for AI. But then you can do certain AI models with simple math, and CPUs might just be fine. So it really depends on what scenario you're executing, what use case, what kind of underlying math is needed, and the requirements of the AI model that determines the silicon choice.
Okay, and how can edge AI models be developed and trained?
Yeah, so mostly a lot of that development and training today is happening in the cloud for very good reasons, because cloud makes access ubiquitous. So distributed development teams can collaborate in the cloud at cloud scale, at cloud speed. In addition to that, a lot of the semi folks and the hardware folks are doing, they're enabling simulation and even digital twins so that you don't actually need the silicon or the hardware before you start development. You can start development, so it's like a shift left, if you will. Okay. And so you do the development, and then you can run simulations and validation and verification in the cloud with either emulation layers or virtualization layers. And then once that model is done, you can then connect it to a real world box or a silicon and validate and test it. So I think AI development today will happen in the cloud, and it will continue to be so. But increasingly, the deployment and operations will really be at the edge.
Okay, Avijit, thank you very much for the information and your time.
No, great. Thanks for the great questions.
Thank you.
Thank you.